Hi everyone! Today we're going to be talking about the vertex form of the absolute value function. Our objective for today is that students will be able to use vertex form of an absolute value function to identify the vertex of and graph absolute value equations and inequalities. Let's get started. Alright, so we've got a secondary warm-up here just to warm us up and remind us of absolute value functions. So number one, what I want you to do is identify what is the parent function of an absolute value equation. Alright, hopefully you guys all remember last lesson we talked about parent functions. So just want to remind you that the parent function of the absolute value equation is f of x equals the absolute value of x. Alright. Now, number two, we've got 6 different functions here, and I want you to describe how the following functions compare to the parent function we just wrote in number 1. So what I want you to do is pause your video and try to describe what is happening, how A through F compares to our parent function. What transformation is occurring? So go ahead and pause your video. When you come back, I'll have the answers written on your screen, and we'll go through it together. All right, so for A, you should have gotten that it is shifting to the right 5 units because when we have -5 inside our absolute value bars, this would be x minus h. Therefore, this tells us it's moving to the right 5 because it's inside the absolute value bars. For B, it's on the outside of the absolute value bars, so when it's on the outside, that tells us up or down. So because it's +9 on the outside, this means we're going up 9 units. For C, because there's a negative sign outside the absolute value bars, this tells us we're reflecting across the x-axis. If it was inside the absolute value bars, that would be reflecting across the y-axis. For D, the 3 on the outside tells us that we're going to have a vertical stretch by 3, and the -2 on the outside of the absolute value tells us it's shifting down 2 units. For E, the 1/4 outside the absolute value bars tells us that there's going to be a vertical compression because this is our A. When the absolute value of A is less than 1, that's a vertical compression. So basically when it's a fraction between 0 and 1, vertical compression. So this is a vertical compression by 1/4. And then the +6 on the inside of the absolute value bars, so the inside tells us left and right, and when it's plus, that means left. So we're moving left 6 units. Then over here, F, negative sign on the outside tells us reflecting across the x-axis. +7 on the inside tells us left 7 and down 2 because we've got a -2 on the outside. So a quick summary is the horizontal and vertical shifts describe the location of the vertex. So all of our horizontal and vertical shifts, so if we have horizontal would be on the inside of the absolute value bars, vertical would be on the outside. So these tell us what happens to our vertex. All right, when we're reflecting it or we're stretching it or we have a compression, that doesn't really affect the vertex. That affects the entire graph. So because all of those horizontal and vertical shifts will affect the location of the vertex, we can use something called vertex form of an absolute value function. The vertex form of an absolute value function is written as, all right, there's a special formula you need to know. So we write it as f of x equals a times the absolute value of x minus h plus k. All right, so this is the absolute value function in vertex form, where where h comma k is our vertex. So h and your k are your x and your y points of your vertex. And a is the slope on the right side, and -a is the slope on the left side. All right, we're going to go through a few examples and kind of interpret what this means. All right, so example number 1, we want to give the vertex of each equation and inequality, and then we want to graph it. So we need to know vertex form of absolute value is f of x equals a times x minus h plus k. And we know that our vertex is h comma k. So what we need to do is identify our h and identify our k. So therefore, our h is going to be 2, and our k is going to be -4. All right, the key thing to notice here is that the negative sign doesn't go with the h because it's x minus h. So when we're looking at h, we're just looking at the number. However, with k, because it's plus k, if we have -4, the negative sign goes with the 4. All right, so this is going to be our h. Hold on, let me write that in a different color. So 2 is our h, -4 is our k. So our vertex is going to be 2, -4. So we identified the vertex. We gave the vertex of the equation. Then we want to graph that vertex. All right, so we go to 2, down 4, put a dot. And then if we want to graph it, we know what the absolute value parent function looks like, right? It's just up 1 over 1, up 1 over 1, up 1 over 1, left 1 over 1, left 1 over 1, left 1 over 1. All right, so all we're doing is we're graphing the parent function, but we're moving it to the right 2 and down 4. So that's how we can use the vertex form of absolute value functions to graph it much easier. We just identify the vertex and move the entire parent function to the right and down, or whatever our transformation is. All right, then we connect our dots, so we're drawing our graph. Then we want to be sure to make sure it's going forever in both directions, and we just graphed it. We didn't need to make a table. This is kind of like the shortcut to graphing whenever it's given in vertex form. All right, so number 3. This is given in vertex form, and we know vertex form of absolute value is f of x equals a times x minus h plus k. All right, so what we need to notice here is that the inside, our x minus h, is written as x plus 1. So this is the same thing as the absolute value of x minus -1. All right, that's what I want you to notice here. Because we can rewrite plus 1 as x minus a -1. Therefore, now this follows x minus h, x minus h. So our h is actually -1. Okay, so if we're writing our vertex, h is -1, k is -2. All right, so k is always just whatever it is on the outside, same sign. H is always the opposite sign. And there's our vertex. Then we need to identify our a here. We have an a that's not 1, so we have a equals 2. All right, and a tells us the slope of our graph on the right side. So if it's slope, we want to think rise over run. So the slope on the right side would be up 2 to the right 1. And then negative a, if we make a negative, so we say -2 over 1, that's going to be the slope on the left side. Okay, so let's start by plotting our vertex. We're going to plot our vertex at -1, -2, so that would be right there. And then the slope on the right side is going to be up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. Now we know that our slope is -2 over 1, but we don't want to go down. So what we want to do is we want to put the negative sign with the 1. So what we want to do is we want to go up 2 and to the left 1, okay? Up 2 to the left 1, up 2 to the left 1, because we want our graph to look like a V, all right? Because it's an absolute value function. So there we go. We've got our graph. Now we just want to connect the dots. So we've got our this side, connect the dots over here, draw our arrows going in both directions, and there is our the graph of our absolute value function, all right? And we graphed it easily using vertex form. We didn't have to make a table. All right, I want you guys to try to graph number 5 using vertex form. So identify the vertex and then graph it on the graph. So remember, you have an A, so remember your slope is going to be different. It's not going to be the same as our parent absolute value function. All right, so go ahead and give this one a shot. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. All right, so your graph should look something like this. Your vertex should be -1, -1, and you should have had a slope of up 2 to the right 3 on the right side, and on the left side, you should have gone up 2 to the left 3. So how did we get there? So first thing we want to do is make sure it's written in standard form, or not standard form, in vertex form, all right, and identify x minus h. So if this is x plus 1, we have to change this to x minus a -1, all right? It always has to be x minus h so we can easily identify the h. So therefore, our h, or the x-coordinate of our vertex, is -1. And then because our k is -1, -1, the y-coordinate of our vertex is -1 as well. So -1, -1 is our vertex. We plot that on our graph. Then our a, which is 2/3, tells us that our slope is going to change. So it's not just up 1 over 1, up 1 over 1, like our absolute value parent function. We're going to go on the right side, which is just our positive a, we're going to go up 2 to the right 3, up 2 to the right 3. So from our vertex, we went up 2 to the right 3, up 2 to the right 3. Now negative a, so if we make a negative, that's going to be our slope on the left side. And we always want to make our run negative because we want to go to the left. So we make our run negative and we want to still go up. So we're going up 2 to the left 3, up 2 to the left 3, because our goal is to get our graph to look like a V, all right, because that's what absolute value functions look like. So once we do that, we connect our dots with a ruler, put arrows on both ends so we know it's going on forever in both directions, and we're done. All right, if you have any questions on this, please raise your hand, call me over so I can help you. Otherwise, let's move on. All right, so number 7. Now I'm throwing a piecewise function out at you, and it has an absolute value function in vertex form in it, all right? So don't be intimidated. We're just going to take it one step at a time. So the first thing we want to do, like we always do when we're graphing piecewise functions, is determine where is our domain changing. So we know it's different when x is less than -1, and it's different when x is greater than or equal to -1. So x equals -1 is where our domain is changing. So we're going to draw an invisible line or highlight it just temporarily so that we can see this is where our graph is changing. So we know to the left of this line, it's going to be the linear function 4x plus 2. All right, so we know this is in slope-intercept form, just like the line y equals 4x plus 2. So we can easily identify our y-intercept, which would be positive 2. And then our slope is 4, so we're going to go up 4 to the right 1. All right. Then we can also go down 4 to the left 1, down 4 to the left 1, and down 4 to the left 1 would be somewhere down there. Okay. Now we want this line when x is less than -1. So at our domain change, what we want is we want this line to the left of that. And because it's less than -1, we know we're going to need an open circle here. So we want an open circle at -1. Oh, that was a really bad open circle. There we go. An open circle, and we want it to the left of -1. So we want these points. So what we can do is erase the points that are to the right of it. All right, because we don't need the points that are to the right of our domain. We only want the points that are to the left. So then we're going to use a ruler, connect our dots. All right, draw our arrow so we know it's going on forever in that direction. And we have the left side of our piecewise function. Now the right side is an absolute value function, and it's in vertex form. So we can easily identify our h, all right, and we want to recognize that this is x minus a -3, okay? So then our h is going to be -3. So for our vertex would be -3, and this is essentially plus 0, right? So our k would just be 0. Now we've got our vertex, and we know that our slope is going to be changing as well. Because it's negative, we know it's going to be going down, okay? And our slope, or our a, is -3 over 1, and our negative a would just be -3 over -1, all right? We make both of them negative. That's where it's a little different when our slope is negative. Instead of making a double negative positive, you want them both to be negative because we're going to the left and down. All right, so what we want to do is first plot our vertex. We know it's at -3, 0. So that's, what am I thinking? That's not right there. -3, 0 would be over here. All right, and if we were to draw this in, we would want it to be going down 3 to the right 1, down 3 to the right 1, down 3 to the right 1, which would be somewhere around there, okay? And then if we were to go to the other side, we would go down 3 and to the left 1, down 3 and to the left 1, down 3 and to the left 1. All right? However, we only want this absolute value function when it's x is greater than or equal to -1. So we only want these blue dots that are to the right or on x equals -1. So we just want this dot and this dot. We can erase all of these blue ones because they don't fall in the given domain for that function. So we erase these because we don't need them. Connect the dots we do need. All right, so we want our graph on this side. Let's see if I can move that. There we go. And then, oh, that didn't work. All right, and then make sure our arrow is showing it's going on forever in that direction. And there you go. All right, so now you graphed the right side of the piecewise function. And if you're able to, you can get rid of that highlighter, all right, or that invisible line you drew to show where the domain was changing. It's a little hard for me to do here without destroying the entire graph, but there we go. Got rid of most of it. And there's your piecewise function with an absolute value function in vertex form completely graphed. All right, if you have any questions on that, please call me over so I can help you. Otherwise, let's move on to our final example. All right, so number 9, it's an absolute value function and it's in vertex form, but it is an inequality. So we talked about graphing inequalities previously, about graphing absolute value inequalities using a table. It's the same idea using vertex form. So things we have to remember when graphing absolute value inequalities is if it is less than or greater than, we want to use a dotted line. If it's less than or equal to, greater than or equal to, we use a solid line. If it's less than or equal to, we want to shade below. And if it's greater than or equal to, we want to shade above. All right, this should all be reviewed from when we graphed them a couple lessons ago. All right, so what we want to do is look at our function that we're given, and it's in vertex form, so we can easily identify the h and k. So our h would be -4, because remember this, we want x minus h, so this is x minus a -4 here. So our h would be -4, and our k would be -6. So our vertex is -4, -6. So we plot that on our graph. That would be right about there. All right, now there's no a in front of the absolute value bars, so therefore the slope is just like the parent function. All right, we just go up 1 over 1, up 1 over 1. If there's no a, our slope is just 1, so our slope is just up 1 over 1, just like our parent function. All right, all the h and k do is tell us where we're moving our vertex. So we've got our graph graphed. All right, we've got all of our points. Now because it is less than or equal to, we know, oops, I didn't want it to overlap that. Let's see if I can change that a little bit. Hold on. Nope. Okay, well, I'll just circle it. So we want less than or equal to, so it's going to be a solid line. And then it's, oops, less than or equal to, so we know we're going to shade below. All right, so we want a solid line and we're going to shade below. So using a ruler, we want to connect our dots using a solid line, and we want to extend it as far as it can go. And then on this side, we want to extend it as far as we can go until it goes off the graph. Make sure you draw your arrows so that we know it's going forever in both directions. And then we want to shade below the graph, so we're going to shade down here, below our graph. All right, and then we're done. All right, so this is how we can graph absolute value functions that are inequalities using vertex form. We graph them the same way, we just don't need a table this time. All right, so hopefully these little shortcuts, or this shortcut, graphing via vertex form instead of graphing by table, will help you graph absolute value functions. If you have any questions, please raise your hand, call me over so I can help you. Otherwise, look to the board to see what to do next, and I hope that you have a great day.